Hi everyone, thanks for joining us today. My name is Anthony Alvarez, Polypropylene Account Manager, and with me today I've got...
I'm Matt Hennigan, I'm a tech trainer here at McElroy University.
And today we're going to be covering some tech tips for the EP800AD hydraulic power unit. Those three tech tips that we want to be covering today, Matt, are what?
So first we're going to start with these fuses and fuse holders up top here. We're going to then cover these outlets that are part of the power management system. And then finally we're going to talk about a pressure dump valve that's tucked away underneath this cover.
Sounds great. Let's get into it. All right, Matt, we're standing here in front of our EP800AD. The first tech tip that we want to talk about today is going to be the fuses. So tell me a little bit about our fuses and what we see out there on a day-to-day with our hydraulic power unit.
Sure. So first and foremost, I want to talk about this. These fuses are located up here on the operator's console, kind of below the on-off switch. This particular one is 120 volt HPU. So you'll notice there's actually 4 fuse holders here. We're only using 2 of them for the 120 volt. You may see a 240 volt that uses all 4 of these, but in common, we're using 120 volt.
And it's my understanding that the 120 volts are the predominant, you know, the most common ones you're going to run across out there in the field are the 120 volts.
Yep.
240s you'll see every now and then, more of a rarity, but the 120s are super common, like the one we have in front of us today.
Yep.
Right? So before we bust into these fuses to do whatever tests or whatever we need to do, what common tools do we need in order to conduct this tech tip?
Good question. It's pretty simple. Flat blade screwdriver,
okay,
and a multimeter. You don't need to have a fancy multimeter. We're going to be using continuity test on this, so we'll just jump right into it.
Okay.
Flat blade screwdriver. This will unscrew. There's 2 parts to this. There's the part that actually holds the fuse, and then the housing that's on the console there. So we can just pull this fuse out, and then we can just test it using continuity. So if I could get you to give me a hand.
Absolutely.
We'll set that there. We'll select continuity on our meter, and to test that I usually will take and touch my leads together. You should hear it beep.
There we
So
go.
we know that's good. So we'll just go on either side of this fuse.
Okay. Sounds like we've got a good fuse.
So we know that fuse is good. So set this back over here. This is an important part. When you're putting this back together, make sure you get that seated in there well. But also, before I put that in, I guess, let me show you guys this. There's this orange gasket that is on the fuse holder itself. That does a couple of things. It's going to seal out moisture.
It's going to be your indicator that you fully seated that fuse holder down, right?
Right. It's going to ensure that that thing is all the way seated. So put this back in, screw that back down. And I want to get down here and look to see that that gasket is not showing. So when we tighten this back up, this is a plastic housing. So you don't have to get too tight with this. You can actually strip this out if you go too tight. And when I say strip this out, you can either strip the threads because they're plastic, or you can actually strip the slot out on top. So you want to be careful of that.
Right, so that's definitely something you want to get it tight enough to where you don't see that gasket anymore, but you don't want to go crazy on it and over torque it and do all that kind of stuff as well.
That's right.
As far as the fuses that are in here, are the power supply and the motor, because I see they're both labeled here, are both of those the same amperage or do they differ?
They're not, and I'm glad you brought that up. So the motor fuse is going to be a 5 amp fuse. The power supply fuse is going to be a 2.5 amp fuse. Now, if you take those both out and test them at the same time, you want to make sure that you put them back in the correct spot because the motor draws more amperage than the power supply. If you get them backwards, when that motor kicks on, it can blow that fuse.
Right. Well, that makes sense, right? Because then you're putting that 2.5 amp fuse in a 5 amp slot. It's going to blow.
Right.
So let's just say, for example, our motor fuse is blown. And this is plugged in. What are you going to experience as the operator when you go to turn on that hydraulic power unit?
So the motor's just not going to spin, right? Can't get power to it, so your motor's not going to run. So conversely, the power supply, if the fuse is on that is blown, you're not going to have power, and there's indications of power supply being on, tucked away under the machine, under the cowl. Okay,
well perfect. That sounds like everything that we wanted to cover as far as the fuses are concerned on the EP800AD. So I think that concludes our first tech tip of the day here.
Perfect.
Thank you, Matt. Okay, we're back with another tech tip here on our EP800AD hydraulic power unit. Matt, we're over here on the outlet side of the HPU now. What am I seeing over here with these 2 outlets?
So this is part of the intelligent power management system. You can see that it's labeled. We've got the facer, we have the heater. These 2 outlets are going to what are running the facer and the heater. So the way this works is this HPU is powered in this case off of one single 120 volt outlet.
Okay.
You're not chasing all over the job site trying to find a generator, a spider box, or something like that. So one spot to plug in over there, and that's going to take care of the power requirements for both of these. So the way this works is when you turn your phaser on, it's drawing current.
Okay.
Inside of here, it senses that current via CT, and it shuts this heater outlet off.
Okay.
So anytime there's anything plugged in over here, this will go off. So this is always on until something that's plugged in is over here is drawing current.
Gotcha. So the HPU is actually detecting that current going to this outlet, and if it sees something there, it's turning off this outlet.
Right.
That way you just have the one plug to power the HPU, the phaser outlet, and the heater outlet.
Right.
Pretty ingenious little system there. So Matt, why is it important that only one outlet is active at a time?
So we have a power rating or load for this whole system. It's important because you don't want to plug in something that's going to draw too much current and just overload the entire system.
No, well, that makes perfect sense. What are some common things that we see out there for this tech tip video that applies to these two outlets here, the phaser and our heater outlet?
Sure. One thing that I've seen is these have gone in for service. These get pulled apart into 100 different pieces. You go put this back together. These actually get wired backwards, which is not that difficult to do, but they are labeled. So if that's an issue, it's easy to figure out. You can look back behind there and go, oh, they've got the heater and the phaser wiring swapped. So easy enough to figure that out.
Perfect. Yeah, and I've seen these things blown apart before. Almost every wire in this
Right.
thing has a nice label on it telling you exactly what goes to where.
Yeah, it makes it
Same
super
thing
easy.
applies for here.
Yeah. The other thing you want to make sure that's not happening is you don't want to be plugging anything into the phaser circuit that's going to be drawing power.
Not so. No phone chargers,
No
nothing
phone
like
chargers,
that.
no microwaves, none of that stuff. Keep this to the phaser, keep that to the heater.
Yep, that sounds like great advice to me, because if you do have something drawing current here,
It's going to shut that
heater's
heater.
not going to be
Absolutely.
heating up. So Matt, what would be a symptom if our two outlets here were wired backwards when it came back from service?
Well, typically what you see is that your heater just won't ever heat up. So easy indication of that is to just look at the lights on the heater, right? On the heater handle. You can see pretty quickly that that's not going to be on because if they're wired backwards, that side is sensing current and it'll shut the heater off.
Well, perfect. Perfect. That concludes this tech tip as far as our EP800AD goes for our two outlets right here on the back side of our HPU. Let's move on to the next one.
Yeah.
Okay, we're here with our next tech tip on the EP800AD hydraulic power unit. And the next thing we want to talk about, Matt, is the dump valve in specific on these units. So what can you tell me about the operation and the functionality of the dump valve?
Sure, it does kind of what the name implies, right? It dumps the pressure out of the system and off the line set, and it does that when you turn the power off.
Okay, so if that dump valve isn't operating correctly, what would be some of the symptoms that I'm seeing as an operator in the field?
So sure, what I see most commonly is that it just runs and runs and runs and never builds pressure.
Okay, so you're just going to hear this thing running, and your needle's just going to stay right there at zero. Even if you got a data logger hook up to it, it's just going to be zero because that dump valve's open.
It's just
not
and
building
it's dumped
pressure.
straight back to the tank. Yep.
Well, that makes perfect sense. What are some things that we see out there that that could cause that dump valve to have that runaway type of situation to where it's just always dumping pressure?
Sure, it could be a few things. You can have loose connectors, loose wires in the connector, a bad valve. The solenoid itself could be bad. So there's a few things that you need to check to make sure that that's operating correctly.
And really, the most common one that you could see out there, I believe, is there's two connectors under there that are very similar.
Right. There's multiple valves underneath here, and there's a few of them that have this similar connector. They are labeled, but it could be easy enough to get them backwards. And I've seen them come back wired wrong.
And those connectors, I believe in specific, are going to be those 2-pin Deutsch style connectors that you can get one way or the other, depending on what you're connecting to. Okay, so if you do have those connectors backwards, like we said, it's just going to run, stay there at zero pressure. Perfect. So if that is something that you're facing as a troubleshooter or an operator in the field, it's going to be an easy way to get in there and figure out what's going on.
Yeah, absolutely.
Perfect.